So our objective 6.4 is to be able to solve a system with three variables using substitution or combination algebraic ways of solving our systems of equations. So again, we typically look at our system and see, is it set up nicely for substitution? Does it have an x equals, a y equals, or a z equals? Or could we make one fairly easily to start our process? And so here it would require a lot of work to make a variable alone, so we're just going to leave them as is. The next thing we're look for is a variable that we could work on eliminating easily. So we say typically look for positives and negatives of the variable and then see if we can adjust the coefficients by multiplying the equations by a value. So looking at my equations, I think I'm going to work on eliminating the z's. And again, it's your choice. So if I'm going to work on eliminating the z's, I'll need the same amount, positive and negative, so I can add them to make a 0. So if I use the first two equations, since I have a negative 2z here to make a 0, I need a positive 2z. So I can take the entire first equation and multiply everything by 2 to make that happen. So by taking the first equation times 2, I'd have 4x plus 2y plus 2z equals 6, and I'm keeping the second equation as is. After we multiply, we always add the equations together. And so we can see we've got 5x plus 4y, the z's eliminated and made the 0, that was our purpose, and that equals 2. So I've got one equation with an x and a y. So I want to repeat that process again using two other equations where I could eliminate the z's. So this time, let's use the second and third equation and eliminate the z's. So again, if I have a negative 2z here, I would need a positive 2z to make that happen. So if I take that second equation and multiply everything by 2, I would then have 6x minus 2y plus 2z equals 18. So again, after you multiply, you add. So we'd have 7x, no y's, and no z's equals 14. Well, here we just have a variable to solve for. So we could divide by 7, so x equals 2. This has worked out nicely. So if we know the value for x, perhaps we could put it back into the equation that we have here and solve for y. So if I do that, I can multiply those together. So I'd have 10 plus 4y equals 2. Subtract 10 from each side. So we've got 4y equals negative 8. And then divide by 4, leaving us y equals negative 2. So at this point, we have a value for x, we have a value for y. The only thing that we're missing is a value for z. So what I'm going to do is take my value for x and y and substitute into my second equation to solve for z. So I'm going to work this out to get z alone. So I'll have a positive 2 minus 4 minus 2z equals negative 4. I can start combining some like terms and trying to get z alone. So I could add 2 to each side and then divide by negative 2. Therefore, z equals 1. So it looks like we have a solution of 2, negative 2, and 1. The only way to be sure is doing our check, taking all the values for x, y, and z and substituting them into all three equations to make sure they are balanced. So again, substituting all the values for the x, the y's, and the z's, and working them out, we can see that it works for each of the three equations. Therefore, we do have a solution to our system, 2, negative 2, and 1.